Today, we are diving into one of the most absolutely mind-bending concepts in the entire cosmos, the black hole. And this is the story of an idea so strange, so completely absurd, that for decades, the greatest minds in physics just flat out refused to believe it could be real.
I mean, think about it. That was the central problem, right? If a black hole traps everything, including light itself, how on earth could you ever prove one actually exists? It's like the universe set up the ultimate game of hide and seek, and for a very, very long time, the universe was winning.
And really, that's what we're digging into today. Not just what a black hole is, but the incredible detective story of how we went from chasing a ghost in our equations to staring at its actual shadow across the cosmos.
So our story doesn't begin with a telescope or some grand observatory. Nope. It starts with just pen and paper, where this mathematical phantom first started to take shape.
You know, the first hints were ancient, at least by physics standards. All the way back in 1784, John Michell imagined something he called a dark star. But the real ghost, the one that truly haunted physics, appeared in 1916. Right after Einstein published his masterpiece, General Relativity, a physicist named Karl Schwarzschild solved the equations for a star and found a monster. He found something called a singularity, a point where gravity becomes infinitely strong, a point where all the known laws of physics just completely break down.
But here's the thing. Pretty much everyone, including the giants of the field like Arthur Eddington, thought it had to be a mistake, just a glitch in the math. I mean, as he put it, nature just shouldn't behave in this absurd way. Even Einstein himself tried to prove they were impossible. For decades, the whole idea was just written off as a mathematical fantasy.
But that ghost in the equations? Well, it just wouldn't go away. And so the debate shifted to the very heart of stars, focusing on this truly epic showdown.
Okay, so here's the crucial point. What holds a star up? Well, for most of its life, it's the outward blast of nuclear fusion. But when a massive star runs out of fuel, it comes down to a battle between two forces. You've got gravity, which is relentlessly trying to crush the star into nothing, and fighting back, you have this quantum force called degeneracy pressure. You can think of it like nature's ultimate personal space rule. It's this incredibly powerful force that stops tiny particles from being squeezed into the exact same spot. It pushes back hard against gravity's pull.
So physicists figured out that there were these cosmic tipping points. There's a limit for how big a white dwarf can be before it collapses. Then there's another, bigger limit for an even denser object, a neutron star. But this led to an unavoidable, honestly terrifying question. What happens if a collapsing star is even more massive? What if it's too big for even neutron pressure to stop it? The equations all pointed to one terrifying answer: complete, total, unstoppable collapse.
Okay, let's jump forward to the 1960s. This period would become known as the golden age of black hole research. This is when the ghost story was about to get really, really serious.
And in 1967, the physicist John Archibald Wheeler finally gave this ghost a name. It was perfectly descriptive, a little bit scary, and incredibly catchy: the black hole. The name just stuck, and it really helped launch the idea from a niche academic curiosity into the public's imagination.
And what's just wild is how simple these things turned out to be, at least in theory. The no-hair theorem basically says that once a black hole settles down, you can describe it completely with just three numbers: its mass, its spin, and its charge. That's it. All the complex details of the star that died to create it, they're just erased. This simplicity made them feel less like messy stellar corpses and more like pure, fundamental objects of nature.
And then, finally, the ghost story got its first piece of real physical evidence. Astronomers were looking at this source of intense X-rays called Cygnus X1, and they realized what they were seeing. It was a massive, invisible object literally sucking gas off a companion star, and its mass was way too big to be a neutron star. It was our first serious suspect.
But, a suspect isn't a conviction. Decades of debate still followed. To truly, finally prove that black holes existed, we had to do the impossible. We had to see the unseeable.
And this is such a beautiful twist in the story. After a century of trying to see a black hole, the first ironclad, undeniable proof didn't come from light at all. It came from sound. In 2015, the LIGO experiment detected gravitational waves, actual ripples in the very fabric of space-time that were created when two black holes spiraled into each other and merged.
We couldn't see a thing, but we could hear the unique chirp of their collision from over 1 billion light-years away. It was the first time we had ever directly observed black holes in action. Absolutely incredible.
Now, hearing them was proof enough for the physicists, but that original quest, that original challenge to actually see one, that wasn't over. And in 2019, humanity finally got its wish.
And the way we did it is just a testament to human ingenuity. By using a whole network of telescopes scattered across the globe to create a virtual Earth-sized telescope, the Event Horizon Telescope captured an image, not of the black hole itself, of course, but of its silhouette, its shadow, cast against the glowing, superheated gas swirling around it. The ghost finally had a face.
So with their existence completely confirmed, we've now realized these things aren't just rare curiosities. Oh no. They are a fundamental part of our universe, and they come in a shocking variety of sizes. It's a whole zoo of cosmic monsters.
On one end, you've got your stellar mass black holes. These are the leftover cores of massive stars, maybe the size of a city, but weighing several times more than our sun. Then, at the other end of the scale, you've got the supermassive ones. These are the true titans, millions or even billions of times the mass of our sun, so huge they could swallow our entire solar system whole. And there's even evidence for a class beyond that, the ultramassive ones. The range is just staggering.
And you don't even have to look far to find one, because right at the center of our own galaxy, the Milky Way, sits Sagittarius A star, a supermassive black hole weighing in at 4.3 million times the mass of our sun. It is the silent gravitational anchor that our entire galaxy spins around.
So we went from a mathematical absurdity that even Einstein rejected to a confirmed, photographed, and even heard reality that literally governs galaxies. The story of the black hole is just this amazing testament to scientific persistence, and it really leaves you wondering what other impossible ideas hiding in our equations right now are just waiting for us to find them.